Welcome back, class. So this is the lecture number 2, and in this lecture we will discuss about the relative acidic strength of oxyacids of nitrogen. So in the previous lecture number 1, we had discussed about the structure of different oxyacid, and in this we will talk about the acidic strength along with the some structural information in addition to that lecture number 1. So today is the second. So far as we know that in the previous lecture the oxidation number of different nitrogen oxide, like +1, then +2, then +3, then +4, and then +5. This was N2O, this was N2O2 or NO, dimer of NO. This is N2O3, N2O4, dimer of NO2, and N2O5. This we had already studied. No? Now the oxidation number decide the oxidation, the oxidizing nature, acidic nature. Okay, so as the oxidation number increases, the acidic strength will increase. Okay, oxidation number increases, acidic strength will increase. So here as you can see that the +5 oxidation number is of N2O5. So N2O5 among all the 5 oxides of nitrogen, N2O5 will be the most acidic. Okay, so this is how you can decide the acidic strength. Depends on the, okay, so based on the oxidation state, the N2O5 will be the most acidic. Now there are several other oxyacids for nitrogen also. Okay, so we will discuss briefly here because it is not in as detail in your syllabus. So what are they? So here is the topic is the oxyanion. We will discuss oxyanion of all that acid. Oxyanion. Okay, so in this case again we will take the oxidation number, then the formula and name. So the oxidation number is +1, formula is H2N2 and O2. This is hyponitrous acid. Then the +3 H and O2. This is the nitrous acid. And then +5 HNO3. This is nitric acid. And +7 is also, this is actually very interesting because nitrogen has 5 outermost valence electron. Here the oxidation state is +7, but it is possible in rare cases. HNO4. This is peroxynitric acid. Peroxynitric acid. Okay, so these are the some other oxyacids of nitrogen. Along with this we'll also take the anion, because anion is also important in this case. So anion of this is N2O2, 2 negative, here NO2 negative, sorry, negative, here NO3 negative. This can also be drawn with the Lewis structure, okay, and here NO4. So these are the anions. Now what one more information we can gather here with the help of this oxidation number. See, there is a question. Question is HNO2 act as a oxidizing agent, as well as reducing agent, but HNO3 act as a oxidizing agent only. Why? So this is the question, and the answer is okay. As you can see here, that the hyponitrous acid has +1 oxidation state. Okay, nitrous acid is in +3, nitric acid is in +5. What this actually explain? This is a proper explanation of oxidizing and reducing nature of a given compound. See, HNO2 act as an oxidizing agent. So this is HNO2 as well as reducing agent. HNO2 is in +3 oxidation state, so it can decrease its valency oxidation state to +1 also, or it can increase to +5 also, which is very near to do this. +3 to +1 and +3 to +5. Okay. So as it is can reduce its oxidation state and it can increase also, that is why it can act as an oxidizing as well as reducing agent. This is the reason, because it is in +3 oxidation state and it can increase its oxidation state into +5 also, or it can reduce its oxidation state into +1 also. So +3 is for HNO2 and it can go for +5 also, and it can go for +1 also. Okay, so this is the reason why it can act as a oxidizing as well as reducing agent. One thing. Second, HNO3 act as an oxidizing agent only. Now again the question arises, HNO3 also can increase its oxidation state to +7 and decrease to +3 or +1 also. So it should also act as an oxidizing or reducing agent, but it does not actually happen, because the +7 oxidation state is the rarest of the rare. Nitrogen can maintain +5 oxidation state very easily, but +7 is rarest of the rare. Okay, so here HNO3 can only decrease its oxidation state. So HNO3 can only go for +3 in HNO2. It cannot go to +7. Okay, and this is the reason that it can only act as an oxidizing agent in case of HNO3, oxidizing and reducing agent in case of HNO2. Similarly, you can go for the anion also, no? Why NO2 ion? This is the NO2 minus or NO2 plus is also there. So which type of behavior it will show? So as it is in +3 oxidation state, so it will show oxidizing and reducing energy property both. Okay, so this is how you can answer a question in this way, that one is an oxidizing agent and other one is the reducing agent. one thing. The second thing important here is that the structure of oxides of nitrogen. Okay, as we had already discussed in our previous lecture, this is the detail of that lecture. We had already discussed N2O, then NO, as you can see here, then we have N2O3, N2O4 and N2O5. Now the geometry of these structure, this, so here we will write the geometry. So as you can see that in case of N2O, so it is a planar molecule because this nitrogen, the central atom nitrogen is a sp hybridized. Okay, this is sp hybridized, so it is a planar one. So here I am writing it is planar. Okay, forget about the NO, I will tell you later. N2O3, so here we have structure of N2O3 also. So this nitrogen 1 2 and 3, that means it is sp2 hybridized. 1 2 and 3, this is sp2 hybridized. So is this nitrogen, so it will also, sorry, this is not planar, this is linear. Sorry, this is linear, this is planar. And so and 2 4 again 1 2 and 3 will only count the sigma bond. Okay, so 1 2 and 3, so it will be sp2, 1 2 and 3 sp2, so this is again a planar. So every oxides of nitrogen, this is again 1 2 and 3, so this will give you planar. N2O5 is also planar, so this is again a planar. So N2O3, N2O4 and N2O5 are the planar one, whereas N2 is linear. Now the NO, so the NO, as we already know that NO is available in two form. One is the cationic form, that is NO plus, and other one is the anionic form, that is NO minus, nitrosonium ion. So this is also shows different in its structure. So NO here, NO plus and NO minus. So the NO plus is in linear. This is a linear geometry, that means the sp hybridization is here. And NO minus is in bent shape, so bent shape is can again the sp2. So this is very important, and this is important for the competitive examination also, and for the higher study, that the NO plus is linear and NO minus is a bent. Although the oxidation number will be same, oxidation number is +2 in both cases. Okay, so this you need to remember what is the structure. So the relative acidic strength of oxoacids of nitrogen is based on the oxidation number. As the oxidation number increases, the acidic character will be increased. And we had discussed also the oxyanion, different oxide, nitrous, nitric, peroxynitric acid. Peroxynitric acid, if you draw the structure, the structure will look like this. Here I am drawing. So H, then O, then O, and this is the nitrogen. This oxygen is negative charge, double bond oxygen. This is the structure of peroxy, because here you, if you remember that this is a peroxy linkage. No, this is the peroxide linkage, O and O. So this is peroxynitric acid. It is very difficult to exist. Okay, so this is all about this lecture. Hope you guys understand, and if you have any doubt, any query or any question, please comment in the comment box, or you can send your queries or question to this WhatsApp number. So here is a question for you, the last one. NO2 plus. Okay, NO2 plus. This is nitronium ion. This is nitronium ion. So nitronium ion, whether it is a oxidizing agent or a reducing agent. Comment your answer in comment box. Thank you.